I hear a yes, and I hear a no. Let me ask you a question. Maybe help us answer. Suppose there was no difference in the brakes. Suppose I wasted my 4 hours of my Saturday changing the brakes out. Suppose. What would the averages be closer to then? The cantilever average and the V-brake average. What would they be closer to, Sherry? Each other, right? Wouldn't they be closer to each other? Not the same number, right? There wouldn't be much of a difference. And if I subtracted them, what should I get close to? 0?
0.
0, right? I should get close to, that makes sense, I think.
Yeah.
So, Shannon, say that again. Something just made sense. That makes me happy.
There's a big difference.
There is a statistical difference here. Where is 0?
Way up there.
0's over there. Where's the interval? How far apart are they?
Far.
Minimally about 5.5 feet, maybe even more. Does that make sense?
Yes, right.
Minimally 5.5 feet, maybe more. So there's a minimally about a 5.5 foot difference improvement with the V-brakes over the cantilevers, maybe even more. Does that make sense? If that interval crossed 0, then I wouldn't know which one was better or worse, would I? If that interval crossed over to 0, then it'd be like, well, maybe one's better, maybe one's worse, maybe they're the same. But the fact that it's completely separate from 0 gives me really, really good indication that something is better than something else. Is that fair? Okay, ask me questions right now if you've got them. What confidence are we at?
95%.
We are, aren't we? If we had run 2 separate intervals and graphed them together, we'd be at less confidence, wouldn't we? But we did the whole thing with one calculation. That maintains 95%. That's the goal. And I mentioned this in your exam. I mentioned this at some point in your exam when I have you run that calculation, that this is why we always strive to not do multiple tests, to do one test when possible. Because one test keeps that 95% without destroying it with multiple multiplications. Is that fair? Is that fair? We buy in this?
Yes.
Ask me that question, Rick.
I guess I'm not following why, when you have multiple tests, your confidence level.
Oh, that's a good. Who wants to throw out an explanation? If you have multiple, so if we had made 2 intervals here, each at 95%, the resulting confidence drops. Tell me why. Tell me why. And use your own words. You don't have to use my words.
Because you lose that 5% each time.
Right, here's the deal. I love that answer, Sherry. Max, you gonna say something? Go ahead.
No.
You sure?
Well, when you square 0.95, you drop.
Think of this 95 squared. Keep that in the back of your mind. Think of a confidence interval as the chance that the parameter you're targeting is in the confidence interval, right? We always say 95% confidence. What do we mean by that?
I moved it.
It means, oh, did you? Awesome. I'm going to do this so I can. There we go. Perfect. Thank you, Paul. What does 95% confidence mean?
You're confident. You're confident that your numbers are right 95% of the time.
Exactly. If I run 100 tests, 100 separate independent studies, I'm on average going to catch the parameter 95 times out of those 100. Every single interval has the same 95% confidence. So if I do 2 independent intervals, that means they're both 95% confident. So think of it like this, you're flipping a coin. Think of it as a coin flip. But the coin comes up heads 95% of the time. Tails, only 5%. Good so far? Hopefully that makes sense. In order for us to be right in both of our intervals, what do we have to flip? We have 4 possibilities, but in order to be right on both of them, what has to happen on both coin flips? Don't overthink this. Flip heads, flip heads. Gotta get heads, heads, right? Now, Max is correct. There's actually 4 things that could happen. I could go heads, heads, yay. I could go heads, tails, kinda yay. I could go tails, heads, yeah.
Tails, tails.
Or I could go tails, tails. So there's a chance the first interval's good and the second interval's good. There's also a chance the first interval's good, the second interval's bad. There's also a chance the first one's bad, the second one's good, and there's the last chance that they're both bad. Now, what's the chance of each one of these situations happening? You can find them by using the 95 and the 5. For example, the chance of them both being wrong. That's awful, right? It's also probably not going to happen because the chance of that happening is 0.05 squared, which is less than 1%. There's a less than a 1% chance of you missing with both intervals. Fair so far? The chance of either of these is 0.95 times 0.05. Whatever that is. I don't know what that is. 45% or something. I can't do that math in my head. Actually 4.5%, more like 9% or something like that. Whatever it is, it's pretty small. The chance of this happening. Now, that's way bigger than any of these. But it's still smaller than 95% because it got squared. Does that make sense? Good. And it gets worse with every additional interval that you stack on. This is why I get nervous when I go to the doctor and they draw blood and they do 30 tests on my blood. Because every one of those tests isn't 100% accurate. And if one of them comes back positive, I'm like, okay, was that a false positive? Was that one of these? Right? Was that a false positive? And the ones that come back negative, I worry about too. You're fine. Am I? Am I really fine? Look at me, doc. I'm fine. Right? So the problem with multiple testing is, if you can do it with one test, you maintain that 95. As soon as you start stacking tests on, it starts dropping exponentially. Is that fair? Finger in my ear. Okay? Decent? Hopefully decent. Ask me more questions. That was a fantastic question. Thank you, Rick. More questions if you have them. Maybe. Okay. Let me just... We're going to get a little bit early today. I know you're very upset by that.